Under Module 3B, we will discuss uniformly accelerated motion. Uniformly accelerated motion is a motion with constant acceleration or a motion with a constant change in velocity. Now take note that in uniformly accelerated motion, in each formulas, there are 4 variables that are interconnected. Therefore, make sure that the 3 variables are known and only one is unknown. Let us solve sample problem 1 under UAM. A cat starting from rest runs at a rate of 3 meters per second squared. Find A, the cat's velocity at the end of 4 seconds, B, the displacement after 4 seconds, and C, the distance covered during the 4th second. So let us use an illustration to understand the problem. So we have a cat that started from rest and it runs till the end of 4 seconds. We know that the acceleration of the cat is 3 meters per second squared. So for letter A, the given R, time is equals to for letter A, the given R, time is equal to 4 seconds. Acceleration is 3 meters per second squared. And then we are tasked to solve for the final velocity at the end of 4 seconds. So from the formulas, we will use VF is equal to VI plus AT. So we know that the initial velocity of the cat is 0 meters per second since it started from rest. Then plus acceleration, which is 3 meters per second squared. Then you have here time, which is 4 seconds. So the final velocity is 0 plus 3 times 4, that is 12. However, we have here second, and on the denominator there is also second squared, so the unit will be cancelled. So 1 will remain here, so that will be meters per second. So you have here a final velocity of 12 meters per second. Then for letter B, we still have the same given, which is time is equal to 4 seconds. Acceleration is 3 meters per second squared. However, we are looking for the displacement after 4 seconds. So the formula will be D is equivalent to VIT plus 1/2 AT squared. So we know that initial velocity is already 0, so whatever we will multiply with that one will always be 0 also. Plus 1/2. Acceleration is 3 meters per second squared. Multiply that one to time, which is also squared. So this will give us 0 plus, this is 1/2. 3 meters per second squared multiplied to 16 second squared. So as you can see, the unit of seconds here is in squared, also with this one, so this will be cancelled. So you have now 3 times 16 divided by 2, that will give you 24 meters. So we will solve for problem C. For problem C, it is only interested for the displacement covered during the 4th second. So that is the distance during the 4th second. So we know that this is the distance after 4 seconds, and we know that there is a distance at the end of 3 seconds. So from the previous problem, we know that the distance after 4 seconds is 24 meters. The acceleration is 3 meters per second squared. And we know that the cat started from rest, so initial velocity is still 0 meter per second. So we have to solve for the distance at the end of 3 seconds. Then we have to solve for the distance during the 4th time interval. Okay. So let us solve first for D3. So D3 is just the formula for distance, so that is VIT plus 1/2 AT squared. So whatever you will multiply with a zero velocity is still 0 plus 1/2. Acceleration is 3 meters per second squared. However, we are looking for the distance at 3 seconds, so time will now be equivalent to 3 seconds. Take note, distance after 3 seconds, so this will be squared. So this will now give us, this is 9 times 3, then divided by 2. So the distance at the end of 3 seconds is 13.5 meters. Then, we will now solve for the distance during the 4th second interval. So that will be the distance after 4 seconds minus the distance after the 3 seconds. So that is 24 meters minus 13.5 meters. So that will be 10.5 meters. So the distance covered by the cat during the 4th second interval is 10.5 meters. So this is 10.5 meters. We will now solve sample problem under UAM. As an engineer, you were asked to design a runway for an airport. An airplane that will use this airfield must reach a speed of 30 meters per second before takeoff and should accelerate at 2 meters per second squared. A. How much time does it take this airplane to reach the takeoff speed? B. What must be the minimum length of the runway for the aircraft to reach this speed? So we know that there is a runway in which the airplane should take off. So at takeoff, the airplane must reach an acceleration of 2.00 meters per second squared. And the final velocity at takeoff should be 30.0 meters per second. So for letter A, we know the given R, acceleration is 2.0 meters per second squared. Final velocity is 30.0 meters per second. And we know that the airplane will start from rest. And then we are tasked to solve for time. In the formulas that are given to us, we have the formula Vf is equal to Vi plus At. We know the final velocity, we know the acceleration, we know also this one. However, we don't know the time. So if we will solve for time, we have to manipulate this formula. So we have to transpose this to the other side. So we will have Vf minus Vi is equal to At. But since we are solving only for time, then we have to divide both sides by A. So the formula that we will use is Vf minus Vi all over A. So substitute it now. So this is 30 meters per second minus 0 meters per second all over 2 meters per second squared. Okay, so that will be 30 divided by 2. Then the time will be 15.0 seconds. So that is cancelled, 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 cancelled. So the time needed by the airplane to take off is 15 seconds. So let us now solve sample problem 2, letter B. We know that the acceleration is 2.00 meters per second squared. The initial velocity is 0 meters per second. And you have a final velocity of 30 meters per second. Then we are tasked to solve for the displacement. From the formulas given, we can use 2AD is equal to Vf squared minus Vi squared. Since in this formula we know Vf, we know Vi, and we also know acceleration. So we can use this formula to solve for distance or displacement. So let us divide both sides by 2a. So this will give us distance is equal to Vf squared minus Vi squared all over 2a. So let us substitute the given. D is equivalent to 30 meters per second. Then we have to square this one. Minus 0 meters per second. You have to square this one. All over 2 times 2 meters per second squared. So 30 times 30 will give you 900 meters squared all over second squared. 0. So that will, and for the denominator, 2 times 2 is 4 meter per second squared. So 900 divided by 4 is 225. The unit will be cancelled. That one, that one, that one, and that one. So what is left is meter. So the distance is now 225 meters. We will now discuss the free fall motion. So free fall motion is an application of the uniformly accelerated motion, but this is along the y-axis. So please take note of the changes in the formulas. Also take note that in solving free fall motion problems, we are neglecting the air resistance. Now for the changes, acceleration will be changed with g, d with y, then vf and vi will be substituted with vfy and viy respectively. The acceleration due to gravity is constant, that is 9.8 meter per second squared, or 980 centimeters per second squared, or 32 feet per second squared. And then take note that if the object goes down, we will denote g as positive, since we know that the object is accelerating, and we will denote g as negative as it goes up. Now we will proceed with sample problem 1. For a stone drop from rest, compute its velocity and displacement for the first 3 seconds from dropping. So we have a stone from rest, then it is dropped. Then we will solve for its velocity and displacement after 1 second, after 2 seconds, and after 3 seconds. So we know that the initial velocity along the y-axis is 0 meters per second. Then we know that the acceleration is 9.8 meters per second squared. So for letter A, we will solve for the velocity after 1 second, the velocity after 2 seconds, then the velocity after 3 seconds. So we will use the formula Vfy is equal to Viy plus Gt. So solving now for V1y. So V1y is equivalent now to Viy plus Gt. Take note that the time is equivalent to 1 second, since we are looking for the final velocity after 1 second. So this is 0, since the initial velocity is 0, plus 9.8 meter per second, multiply that one to 1 second. This is squared. Okay, so it's cancel there, cancel there. So the velocity after 1 second, the velocity after 1 second is now 9.8 meter per second. Then for the velocity after 2 seconds, we will substitute t. Instead of 1 second, we will use 2 seconds. So this is Viy plus Gt. So this is still 0 plus 9.8. Multiply that one to 2. So that will give you V2y is equivalent now to 19.6 meter per second. Then for V3y is now equivalent to 0 plus 9.8, multiply that one to 3, since we are solving for the velocity after 3 seconds. So this will now give us a value of 29.4 meter per second. So these are the value of the velocities after 1 second, 2 seconds, and 3 seconds. We will now proceed with sample problem 1, letter B. We know that the stone is dropped. Then we are going to solve for its displacement after 1 second, after 2 seconds, and after 3 seconds. We know that the initial velocity along the y is 0 meter per second. Then the acceleration is 9.8 meter per second squared. So we will solve for the displacement after 1 second, the displacement after 2 seconds, then the displacement after 3 seconds. Then we know that the formula for distance is y is equivalent to VIY multiplied to time plus 1/2 gt squared. So substituting the given, since we know VIY, we know g, and we know time. But to make a distinction between the three displacement, let us use the subscripts 1 for 1 second, y2 for 2 seconds, and y3 for 3 seconds. So this is 0 meter per second multiplied to time, which is still 0, plus 1/2 9.8 meter per second squared multiplied to 1 second squared, since we are looking for the displacement after 1 second. So 1 times 1 is still 1. So this is second squared. This is in the numerator. Then there is a second squared in the denominator. So that will be cancelled. So that is 9.8 times 1 divided by 2. So that will give us y1 is equivalent now to 4.9 meters. Solving for y2. So this is 0 plus 1/2 9.8 meter per second squared. Then that is multiplied to 2 seconds squared. Second squared here will be squared. So this will be cancelled. Then this one will also be cancelled. So this will now become y2 is equivalent to 0 plus 1/2 9.8 multiplied to 4. Okay. Let's put the unit first. So this is 1/2 times 9.8 meters multiplied to 4. 2 times 2 is 4. So multiplying this one, this will give us a value of 19.6 meters. Then for the y3, or the displacement after 3 seconds, so this will now become 0, VIY is 0, the plus 1/2 the acceleration due to gravity, which is 9.8, multiply that one to 3 second squared. Oh, it's limited, so I'll make my writing cute. So y3 is equivalent now to 0 plus 1/2 9.8 multiplied to 3 second squared. So that will give us y3 is equivalent to 9.8 times 3 squared, so that is 9. So 9.8 times 9 times 1/2. So this will give us a value of 44.1 meters. We will now solve for sample problem 2 under free fall motion. How high will a body rise that is projected vertically upward with a speed of 100 feet per second? How long will it take for the body to reach its maximum height? So we know that there is an object that is thrown vertically upward with an initial speed of 100 feet per second. Once the object reaches its maximum height, it will start to fall. Take note that the object goes up, therefore g is negative. So we know from the problem that the acceleration due to gravity in feet per second squared is 32 feet per second squared. Then we know that the object is projected vertically with a speed of 100 feet per second. So for letter A, we are looking for the maximum height. So the question goes, how high? So that is y. Then we know that from the formula, we have a formula which is 2gy is equal to vfy squared minus viy squared. We will use this formula since we know vfy and we know viy and we know the value of g. So manipulating this formula, we will divide both sides by 2g so that we will have a formula of y is equivalent to vfy squared minus viy squared all over 2g. So substitute the given. Since the object reaches its maximum height, it will stop. Therefore, the velocity at this point will become 0. So our final velocity is 0 feet per second. That will be squared minus 100 feet per second, and that will be squared also all over 2 multiplied to the acceleration due to gravity, which is 32 feet per second squared. But take note, again, the object is going up, therefore acceleration due to gravity must be negative. So y now is equivalent to 0 minus 100 feet squared divided by 2 times 32 feet per second. So if we will do the math, that will give us the value of 156.25 feet. Take note that the displacement or the maximum height, should I say, is positive since we have here a negative value and we also have here a negative value. Okay, so this is the maximum height of the object. Now let us solve for its time to reach the maximum height. Okay, so for letter B, we know that the acceleration due to gravity is 32 feet per second squared, and we know that the initial velocity is 100 feet per second. So for letter B, we are tasked to solve for the time that it will take the body to reach the maximum height. So from the formulas, we have Vfy is equal to Viy plus gt. Take note, we are solving for the time, so we can manipulate this formula. So we transfer Viy to the other side, so that will become Vfy minus Viy is equal to gt. Then we can divide both sides by g, so that time will be left. Then we can rearrange that one to have a formula t is equal to Vfy minus Viy all over g. Again, the object reaches its maximum height, therefore the final velocity at that point is 0 feet per second minus 100 feet per second all over 32 feet per second squared. However, the object is going up, so that will be negative. So negative 100 divided by negative 32 will give us an answer of positive 3.125 second. So this is cancelled. This is cancelled also, then this is cancelled. So what remains is the unit of time. So the object will reach its maximum height after 3.125 seconds.